So 4.4, contingency tables, aka double frequency tables. Our goal today is to be able to interpret data displayed in contingency tables. So up until this point, we focused on one variable data, aka univariate data. But today we discussed the need for a new method to display data for two variables, or bivariate data. So we're just going to make some observations around this table. The upper left cell indicates that, so this table is all about the rank and the age of professors at a particular college or university. So each one of these is called a variable. And we're familiar, this is review, as when we only had one variable, it was typically just in two columns where we had a frequency distribution. And then each one of these rectangles is called a cell, just like in Google Sheets or Microsoft Excel. And then you've got, in this table, you have your totals row and your totals column. And then the bottom right is always the grand total. So you could say, we know there's 1,164 total faculty members at this college. So the upper left cell indicates that, be ready, I'm going to call blank. Sydney? 2. 2, great. And that's the one I put a box around. 2 faculty members are full professors under the age of 30 years. And then the cell diagonally below and to the right of the upper left cell shows that 170 faculty members are, Max? Associate professors. Melina? In there. Associate professors in there, what age range? So we're looking at this 170 here. Yep, so in their 30s. Good. The first row total reveals, so we're talking about row total, 68 of the faculty members are under the age of 30, good. Similarly, the third column total shows that, Alyssa, blank of the faculty members.
Wait, sorry,
Blank, so the third column, blank of the faculty members.
Bottom number?
Are assistant professors.
320?
Yep.
Okay.
Because it says third column total, so that's how we land on that one. The number blank in the lower right corner gives the total number of faculty. Which one is that, Alyssa? Meyer? In the bottom right corner. Bottom right corner total. Yep. 1,164. Gives the total number of faculty, and that total can be found by summing the row totals, the column totals, or the frequencies in the 20 cells of the contingency table. Answer the following questions based on table 4.6. So, what is the probability that a faculty member is a full professor and age 40 to 49? Notice it says faculty member. So that gives us a hint on what we're going to put in the denominator of this ratio. So full professor and 40 to 49, that's going to be this 156 out of the total number of faculty, 1,164. And then you should have a calculator. If you don't have one, you want to grab one right now. It's just some simple calculating to do here today. Jacob? 0.134. Nice, thank you. Now number 7, what is the probability that an instructor is over the age of 60? So here, we're looking at instructors, that fourth column. L? Zero. Okay, it is 0, over the age of 60. What would go in the denominator of that one, do you know?
Instructor at age 60 would be 0 to 3.
Yeah, out of 33. So the 33 is because we said instructor. So
Math Excel, does it want us to put 0 or 0 out of 33?
0, simplified. And then what is the probability that a full professor, so that's going to tell us about the denominator, is over the age of 30? So over the age of 30, well, 2 ways to do it. We could add up all of the spots that are over the age of 30, which would be 52 plus 156 plus 145 plus 75, all of that divided by 1,164.
Wait, wouldn't it be divided by 430?
I'm so sorry, yes, thank you. Out of 430, or, oh, did you add them up?
Well, I just subtracted the... Yeah, I subtracted the 2.
Or that, 430 minus the 2 that are not over the age of 30. And then divide that by 430. And what did you get?
428.
Okay. And what, did you do the decimal?
No.
Okay. Anyone do that calculation, Orion? 0.995. Thank you.
That sounds familiar to... Oh, wait, no, sorry.
99.7?
Yeah.
Yeah.
I realized my mistake.
Close. 9, 10, and 11, same idea. It's just that these are written in our probability notation. So probability of A4, it says hint, this is the entire row of values. So probability of A4, A for age, right? We're going to go all the way across and look at that total, 253, divided by the grand total, 1164. So 253 divided by 1164. And, did you get it? 0.217. Thank you. And then probability of A1 and R2. A1, R2, that's 3 out of 1,164. .003, excellent. Now, on number 10, let's change it up. Let's say or here. What if we have the probability of R3 or A4? R3 would be 320, and A4 would be 253, right? So we would have 320 out of 1164 plus 253 and then you have to think about that general addition rule. So we would have to subtract where R3, this column right here, and A4, this row right here. Notice this 36 here got counted twice, essentially, in these two, between these two totals. So we'd have to subtract off the overlap. So subtract the 36. So you could do that pretty simply just by adding the numerators, keep the denominators the same, and then find your decimal equivalent. So 320 plus 253 minus 36, 537 out of 1164, which is 0.461. All comes together. So if you missed 4.3 notes, make sure you go back and catch up on this. Joint and marginal probability. So this is one last example. A lot of it's done for us, but just so we can kind of see this in different forms. Read for us from the top, please, Mars. Uh-huh.
Age and rank of faculty. If there is an example 4.14. Suppose that a faculty member is selected as a room. Identify the events represented by the subscripted letters that label the rows and columns of the contingency table shown in table 4.6.
Okay, thank you. Identify the events represented by the subscripted letters. So each one could be labeled, so R1 would be full professor. Associate professor for R2. Assistant professor for R3. And instructor for R4. A1 is going to be under 30. And then A2 is 30 to 39, 40 to 49, 50 to 59, 60 to 69. 60 and over, like I said, 60 and over. Part B says identify the events represented by the cells of the contingency table. So that would be to say A1 and R2 is the event. The faculty member is an associate professor under 30. Someone give me another pairing. Oh. Give me another combination of an A and an R. Not A1, R2, but any of the other options. A3 what? R1. Okay. A3 and R1. Thanks, L. A3, R1 would be the event, the faculty member is A3, 40 to 49, full professor. And then we have about 18 other ones to name. So I'll give you guys a few minutes to write those down. Just kidding.
Yeah.
I think you get the idea.
I panicked for a second.
Part B, we did right here. Part C says determine the probabilities of the events discussed in A and B, so we're just going to do those two that we just mentioned. So we'll write that as probability of A1 and R2 equals A1 and R2. A1, that's 3 out of 1,164. Which is, what decimal? Jacob? 0.003? Good. Thanks. 0.003. And then the probability of A3 and R1. Ellie? How many are there in that cell? A3 and R1, so we can flip over. You want to phone a friend?
Yes.
Okay.
Oh, wait. 0.052.
A3 and R1, we had 156 out of, is that right? A3. Okay, 156 out of, is that what you got?
It tells us on the next graph.
It's also on the next graph. A3 and R1, 0.134. Thanks, Ellie. You found it. And then,
Where did 1134 come from? That's how it's supposed to be 64, right?
1,000, or sorry, if you divide, is that not right? What is it?
I think you heard what we were saying and accidentally wrote down the wrong number to divide it by.
Yeah, it's 1134.
You were
Thank
saying
you.
before and you accidentally wrote 134.
Thanks. Thanks. You know me. So then, part D, hey, a summary of the results is right here. So the probabilities of any one of these pairings is already calculated for us. Brilliant. Don't have to do all that. But notice that this is how it would be done, just like we did over here, because that will show up again on your practice in Math Excel. You just take the values from any given matching and divide by the total. Lastly, it says discuss the relationship among the probabilities in the table obtained in part D. So we're going to write this out. The sum of the joint probabilities in a row or column of a joint probability distribution, probability distribution, that phrase goes together, equals the marginal probability in that row or column. There's a little more. With any discrepancies due to round-off errors or rounding errors. So the most exact way to calculate the 0.58 would be to go back and calculate the 68 divided by the total and put that value here versus adding up these values, which are rounded, right? So sometimes you'll end up with that kind of situation on Math Excel. So make sure, just calculate each one. And there's that. Concludes our notes for contingency tables. As always, ask if you have any questions.